The 2021 NCLab webinar series, Exploring the NCLab Sampler Mini-Courses. Webinar number 1, the Introduction to Computer Programming, or Karel, mini-course. This webinar series is made possible by a Nevada State Library, Archives, and Public Records continuing education grant funded by the Institute for Museum and Library Services through the Library Services and Technology Act. My name is Sheila Crawford Bunch, and I'm your host for this webinar. I am the Director of Education for NCLab. NCLab is pleased to provide content and support for the libraries in Nevada that will help Nevadans learn about and find jobs in our new technological world. I encourage you to follow along and try the sampler. You can find it in your desktop account in the Samplers course folder or in your browser at nclab.com/samplers. This webinar was recorded live via Zoom on June 17th, 2021. All right, now we're live. This is the part that's going to get recorded. So the past webinars that we have done have had to do with our full courses, and they're pretty long. They take most people about 80 hours to complete. They're pretty intensive training, and we found ways over the years to kind of jury rig them so you can have, say, little kids just do section 1 of Karel or something. And most of the time, if you're working with children, they don't get through the full course. We've had some superheroes, though, through the libraries. Even I think one of our fastest completers was an 8-year-old. Obviously had some genius genes in there somewhere, because it's not an easy course for someone that young. Since we started, there's a lot of products now that are aimed at younger children, including toys even. I saw some really good toys at the Summerlin Library that you could teach functions to a 4-year-old with. It was pretty neat, using wooden blocks. So, that age, of course, is everything's very concrete and sensory in learning. And then as they get older, they're able to interact with things still on the screen. When you do block coding, you're moving blocks. It's still quite physical, but it's online. And really, for most kids, we start seeing abstract thinking developing, just like Piaget would say, around age 12 and up. By the time they're late high school, they have enough background and maturity to hammer their way through a course and take it seriously. It's no longer something mom or dad prescribes for them. They're doing it because they want to do it. And same thing, we did a big shift a couple of years ago to career training with adults. And I have to tell you, it's been a real treat for me to work with them, because adults have a goal in mind. They want a career out of this, and they'll fight their way through the most difficult levels, and they get a lot out of it. It seems like it's a good match for our big courses. We started several years ago developing small modules for Hour of Code. And then we realized we were shifting audiences, so we separated paths with Hour of Code. There's no bad will or anything like that. Love Hour of Code, code.org, what they do. It's great stuff. But what we ended up evolving from those initial little exercises was this series of samplers. And we now have samplers for all our courses. So let's go to the website first. I'll screen share. Let me go to share. Okay, and I'm going to go to samplers. So it's just nclab.com/samplers. And you go ahead and try that on your machine. You can open a separate tab. You'll also see these in the desktop, and let's look at both views. And we're using these for a number of purposes. You could build a nice little workshop around these, but one of the things I use them for is a screening tool. So we have people who come in that want to take this big program with us, because it's multiple courses. Sometimes you need to check for fit and is it a good fit for that person? So by going through the samplers, they get a pretty good idea of, first of all, how our courses work if it's their learning style, if it fits how they learn. And secondly, whether they're going to like it or not. You know, you get this idea, oh, I want to be a data analyst, and you find out, oh, I'm sitting at a computer all day long writing SQL queries, which is a lot of it. That's the bread and butter. So you either like that, you go, this is cool, you know, I'm figuring out how to filter data to do a job that I wanted to do, or you go, oh my God, I can't stand this stuff. Okay, so that's a self-evaluating tool, right? So going back to the libraries have had the full courses for many years, but we're kind of merging some paths here. I know the libraries have also, many of you have career centers, or you're also your one-stop advice, whether you're official one-stop or not. You know, people come in, they need help. They need, I want to learn about this field. I need a job. I need a job that's online so that I don't get kicked out of my job when COVID hits. This is something I hear a lot, that it made people acutely aware of job security and also being vulnerable. You know, if you're interacting with a lot of other people as part of your job, you're more vulnerable. And then some people really, hey, remote work, I love it. I don't have to commute. I can only go in when I need to. You know, people have had a little taste of that and they want more. And then also people are realizing tech has just invaded absolutely everything we do. So, so even if they don't become a full programmer or a full data analyst, even going partway down this path is going to help them with whatever job they get. So, so we have the samplers, and like I said, these are available right in the browser, and they're also available on the desktop. You're going to see my big messy screen here with a ton of courses because I'm admin, but it'll look like this little box here. It says samplers, and then there's all the samplers as course tabs in the normal desktop environment, and you just start them. So we haven't, the K-12 version is not modified yet. It's just cloned from this one, the Karel mini course. But we're going to make a very simple language version of it so that it can be used with a younger age group. This one goes into a lot of the technical language that you would be expected to learn if you're going to go into programming. So it just kind of introduces it. So you can, today, if you want, you can go this route on the desktop, or you can try it this way through the browser. And it, for instance, if I click on Introduction to Computer Programming, which is Karel, it's just got a fancy grown-up name. It'll open up this screen, and then you can simply start. And then it's got these pretty cards, but guess what? When you click on that, that's starting to look familiar, right? It's going to look the same way as on the desktop. So if I open that Karel mini course and go to the first level, it looks the same. So internally it's the same. It just has a little bit different face on the website. I had some interesting experiences lately. I've been working with some WIOA candidates that are looking, you know, they're going through unemployment and welfare. So a lot of them are coming in with, this is really brand new everything to them. You know, they can kind of turn on a computer, they can put emojis on their phones in response to Instagram posts or whatever, but they're pretty green on everything, on technology, on the culture of working in technology. And I suspect you're going to find some people coming in there. So what I've done with them, I've done a little one-on-one to get them started. And I'm amazed that doing this little bit of a start makes a big difference for them. So I'll walk them through this part. And you can see some of these things are interactive. You know, it's just it's a HTML graphic. So that's something, if you want, you can explore language. I would go back to it later because one can get impatient waiting to get started. but I'll walk them through a couple of screens that explain the language. And then this is where I want to make sure they can interact with this. And you might find this with your patrons, whether you're working in a group or they've just sat down at one of the computers at the library. It's not intuitive for everybody on how this interface works. So the very first level, and you can follow along as I'm doing this, is a demo, and it explains what the step button is. It also explains this thing called the status bar, which shows up down in this corner. It's pretty small. And then, of course, you have the maze layout here. And there's Karel, the robot. There's an apple that he can collect. There's the basket he's supposed to put it in, and the home square. And then there's some things you don't want him to run into, so we're going to avoid those. I got to show you a feature. This is brand new, literally today. It's called accessibility. So for a lot of people who have poor eyesight or some kind of visual problem, these are very pretty, but they're very hard to make out. So especially if you're, say, red-green colorblind, that apple's a little hard to see. You can kind of see something is moving until you mouse over it. But even if, let's say you're using keystroke navigation, you're not going to see the mouse overs. So this little button that toggles it, that makes it obvious. You can see where all the objects are and start planning out what Karel needs to do. And if you want to go back to pretty, there it is. So this is brand new today. I'm very happy about it. Last year, we tried to make things more accessible. We're working much better with text readers. Navigating from different levels is you can do it by keystrokes. And just before I go back into this, okay, I'm going to show you up here. There is an accessibility key now, and it explains all that, how to use the keystrokes. So if you have someone that might need some different controls, and please let me know if you run into someone who needs these features. You know, we've developed these things. We'd like to see how they work with real people. You develop them because you have to, you know, it's a government requirement, but you definitely want to see how well they work for people. So going back to Karel, I'm going to go back here. Okay, we're going to go and step through this. So I always make sure that they know where things are. This is the coding window where they're going to write their code down here. Up here is where they're going to read the instructions. And over here is where they're going to see the results. So we start stepping through. And this is where, and it's really tiny. I've clicked the right command and it tells me in plain English what right means. It says, I will turn right. And Karel turns right. And then the next one is that we're going to click on go. I will make one step forward. And then I will pick up an object from the ground. Okay, that's what the algorithm is. Then I will turn left. I will make one step forward. I will make another step forward. I will place an object on the ground. So he's putting the apple in the basket now. I will turn right. I will make one step forward. All right, so because it's a demo, it automatically completes. And that's how it used to work when you're running your old code, but we changed how it works. So I'm going to show you how that is. So, okay, we're happy we passed this demo. Yay, 1.1 is done. It does review the commands, and Karel only has 5 commands. Karel can only do 5 things. Move a step forward, turn left 90 degrees, turn right 90 degrees, collect an object, or place an object. That's all Karel can do. This is good, though, because when you're dealing with the real world, you're dealing with limitations. All computer programs, even the most sophisticated, have limitations. So Karel's already forcing you to go, I got to do what I need to do with these limitations. So there's a little review on point of view, that Karel's left is Karel's left, not your left. So for instance, when he's facing south, his left is going to look like our right, and that sometimes takes some getting used to. Something that's also new is before you get to that graded task that passes the level, that tests your ability, we now have exercises. And so you can press that button, it'll open this page, and this is the first time you're actually writing a piece of code. So here's Carol, there's a pumpkin, there's the home square, and the instructions are to collect the pumpkin and enter the home square. It says your program should have 3 lines, and it tells you what to do. You press the play button to run it. If you need to restart, and that won't show up until after you've run, you press the restart button. And you can see in the exercises, they get the solution too. So we're not going to make them hard when they're learning. Okay, if they really don't get how to do this, they can click on the solution just like you can as a teacher on the real tasks. So this is sometimes something they don't know is, where do I type my code? Well, it types in here, and then they go, well, what do I do now? What do I do? Tell me, what do I do?
You hit the play.
Nope, I could.
You're talking about like in the code? Yeah, get.
How do I put get? What do I have to do first?
Return.
See, now this is something that's, if you've done this before, or if you kind of know how coding works, you know, you hit the return. A new person might not know that. Okay, so we got go. Somebody already said we got to get. Yes, we got the pumpkin. What do I do now?
Enter.
Go.
Right. Okay, and then I got to go. So I've got 3 lines. Yeah.
In the old one, I thought it in, not the old one, like in Carol the Robot, I think it intentionally told you had to start a new line for each. Like as you're going through on the full version, it does tell you have to hit enter each time you enter a new command, and it does tell you like when to space in also.
Yes,
like
and it does in this as well. It does in this as well. But in these exercises,
this is the first one.
This is kind of like the discovery part, right? Okay. So okay, so now, and I could either step through it or run it, but I'm going to run it. Okay, you notice you don't get the fireworks and stuff. So what that does is, let's say I didn't have that third command in there, and I'm going to restart it, and I press run. Okay, I can look at it and I can go, oh, I only have 2 lines and I didn't end up where I needed to go. All right, I'm going to write go. I'm going to try it again and try it again. And now it looks correct. So this is more like real programming, where you get to debug your program in peace without someone being snarky about it and saying you fail, right? The old one, it ran, and all of a sudden you found out, oh, there's sad Carol, I failed, right? This is more like our other courses. We made Carol behave like everybody else, but it's also more like real programming. You're not going to send some code to your boss until you're pretty sure it works. So now we're sending it to the boss, right? This is submit. Oh, we're brilliant. Oh, yeah, we do that. Okay. All right. So then it just keeps going. So that's the exercise. So now I've done the first exercise. Now what you're going to see here in the next couple of weeks is this will change color if you've done it. But now go ahead and do those 3 exercises. And you'll see how they build on each other.
Zowie. I know.
Happy Carol.
Okay.
Okay, all right, everybody's done. That's awesome. So if you're doing this with a group, you don't have to wait like I did on everybody being done. You could, for instance, you're going to have some people who they're very comfortable figuring it out as they go along. You can just give people permission to get started, and then work with the people who need your help if you're working in a group situation. But I think you saw how the exercises build, right? They start dead simple, and then the add a little bit and add a little bit more. And then now you're going to go to the graded task. So you go ahead and type that in, you submit it. And I think I must have already done this one. So I'm just going to run it. Oh, I made a mistake. Huh. Okay. What did I do wrong here? I got way too many lines. Write a program for Karel to collect the basket. So I'm going to just cheat because I don't know what I was doing there, but I'm just going to run it so I can get you guys continuing. And so you understand now about the run versus submit. And then this is the first graded task that would give points. Okay. And then there's always a little bit of a discussion. If they didn't choose to use the solution to help them solve it, it does go over it with an explanation. And then you're going to have a bunch more tasks. So the way this works is it's in groups of 3. And I've made some notes here for you guys, which I'll send out. I got to pretty it up a little bit. Let me make it fit so it's a little bigger. No, that's not big enough. Let me do this. Okay. Zoom windows, move over so I can see it. Okay, so you can see it's all set up in groups of 3. You have 3 levels that have to do with typing with the basic commands. Then you have 3 levels that bring in the repeat loop. So now you're working with control structures and looking for patterns. Then you have 3 levels that work with if statements. So they're learning how to build conditional programs. And finally, you do 3 exercises with the while loop. So that's now a control loop that's conditional. And that's where we stop. We used to, in the old hour of code, we went on and on. We brought in all kinds of other skills. But really, if someone is getting introduced to this, this is enough. So I'm going to leave you to it for, how about 15 minutes? And I'll check in 15 minutes to see where everybody's at and what your thoughts are, you know, both as a user and as an instructor, and also as a curator, thinking about who you would use this with. So in the meantime, if you want to shoot me a message in chat, please do. But the floor is yours.
Howdy, I got a quick question.
Mhm.
Okay, so the discussion on page 5 of 2.1 talks about the counting loop.
Right.
Yeah, so I had a bit of like coding experience in college and whatnot, and like I've taught some classes and everything, and where it says the counting loop is a control flow statement. Is there any way that could have like a little hover thing where I hover over it and it has like a little definition, or anywhere in this sort of like, what would you think, as somebody who's taught a lot more coding than I have, would be a good like low level sort of definition? If anybody's like, what the heck's a control flow statement? Okay,
so yes, we could do something like that where you had a tooltip that explained it. Depending on your audience, what I prefer to do instead is look it up. Control flow statement.
So make it into a lesson. Like,
yes.
Be like, does anybody know what that means? No? Okay, well now let's
Google it. Okay. So, oh my goodness, look what I've got here. I've got flowcharts, control flow. I've got a big Wikipedia going here. I've got I've got documents from Oracle. And the reason why I would point it that way is because, again, what are we migrating towards? Maybe you're going to do a job in this field. Even if you're a middle schooler, or you could be someone coming off the street going, I can't stand working construction anymore, my back hurts. I need to do something else that's not going to kill my body. You want them to start being self-sufficient.
Yeah.
So that's what I would do. And that's a really good question you brought up. But with our trainees, same thing. I point them, you can Google it. If they're learning Python, I encourage them to have python.org up, available. If they're learning SQL, PostgreSQL up. I encourage them to create an account with Stack Overflow. Just get into that world of online work. So yeah, let's see what it says. What does Wikipedia say? Okay, control flow or flow of control is the order in which individual statements, instruction, or function calls of an imperative program. Oh my goodness, we just threw in about 5 more vocabulary words, didn't they? So this might be a little dense for people because they're already getting highly technical on what control flow is. Sometimes what I find is these little Google pop-ups. And again, that's super technical. At the level of machine language or assembly language, oh my God, you're going to lose people right there, right? Control flow instructions usually work by altering the program counter, but oh, there's a clue. What are we working with right now? We're working with counting loops. So I think, it could be a bit of a rabbit hole, but I would encourage people to go through it. And now I'm finding, there's 3 types of control structures.
So it's kind of there in NCLab to make people ask the question that I asked, like, what is,
Yes.
Like,
yes.
So, and I suppose depending on the level of the group, there's different answers.
But I think, this is something I really like that Pavel wrote in these post discussions, because one of the concerns I've always had with Karel is it looks like a kid's game, So I got to tell you, it's worked really well with adults. It really has opened doors. Usually they get thrown into a formal programming language too soon. They freak out and they're done. This is a way to get into the essence of programming with a very simple script. But these discussions show, hey, you know what? This is something that all these languages do. And giving some ideas. Karel's using repeat. That's a counting loop. Python uses for. They have do for Fortran, and the example from COBOL. But it gives you an idea that what you're learning is important and significant. Learn a repeat loop. All you have to do is change how you write it. Now you're working in another language. So I think, though, I'm going to make a note of that, because I love that you guys are bringing these things up, because if it's for instance, if that's a stopper for people, and we just did an investigation, and what we found out was all the explanations for control flow statement are pretty complex.
Yeah.
Right.
Like like I said, I had done this earlier today.
Yeah.
I just remember, like, as I was going through it, just going, oh, this is the part of the code. This is the part of coding that I forget. That at the end of the day, it's like some linguistic stuff.
What's ironic is it's actually fairly self-explanatory. You're controlling the flow of the program, right?
Exactly.
But our brains want to make it much more complicated.
Yeah. Because that, and the Wikipedia definition was very complex, but you could just be like, it is a type of the statements that direct the program down a certain path.
Yes. So what I would love to do if I was running a group, I'd have I'd have those those sticky posters that you put up in flowcharts, and what do you call it? Not flowcharts, just chart paper. You put them up and you write a question at the top, and then people start filling in what they think it is. And it's a great way to get a discussion going and a collaboration on what the definition is. And I think it speaks to multiple points of view too. What does this mean? And there's some great, in the teacher notes that I've made for this, I put some leading questions in. So if the group's a little not sure where to start, you can throw out some leading questions and get them thinking. Okay, Lori brought up a point. I'm going to scoot over to there. Okay, she's already in the conditional programming. So in the conditional programming, I'm just going to go to one of the exercises here. You'll see multiple mazes. You see the different colored squares up in the right corner there. And the whole idea is that when you're writing the program, it should work for that range of conditions. You're no longer telling Karel exactly what to do. You're writing in if statements to check for things and then do something. And if I click through these 4 boxes, you can see, I'm gonna go to the accessibility because I think that shows up really well. You can see that there's the orchids are on different squares and there's different numbers of them. Yeah. So we want our program to work for all of these conditions. Okay. Now, when you run the program, I'm going to do a little cheat here, put the solution in. Okay, so here we've got the repeat control structure. He's always going to make a step forward, but then he's got to check if there's an orchid. And if there's an orchid, they're going to pick it. So after you've run it, okay, all right, that looks like my program is running. If you want, you can manually test all of these, but guess what? When you submit it, it does it for you. You see that? Yeah, which is pretty cool. I love that we did that. We never did that before. You know, it's like you've got all these beautiful alternate mazes that people are oblivious to. They don't see them. So now when you submit, you see it. Yeah.
Now, because I think it was only grading the one and then it would grade okay sometimes. And then sometimes you would try and do it and it would say, nope, it didn't work. And you're like, gosh, I just did this, but it would be the different maze. And that's when we figured out to like toggle at the top between them, because then you can see like where your rule might not be working.
Exactly.
Like in one maze, it might look like every time you hit a wall, you had to turn left or something. But if you look at the next one, it wasn't always a left or something like that.
So this again, what are you doing? You're shaping your thinking as a real world programmer. Is my program going to work under, first of all, I'm thinking it's going to work under these conditions. And typically that's when you start hitting bugs, right? You write this beautiful bit of code, you publish it, it's live, everybody's happy except for that one person in 100 that hit a bug. And that was the condition that program didn't work under. So that's very much the real world experience of a programmer. In this case, again, it's very simple. It's graphic, and I'm in love with my little accessibility guy because it's super easy to see the objects. Ooh, is that because I saw? Oh, that's it. I have to resubmit. That's interesting. Once it's done, it disappears. Maybe. What's going on there, Karel? Okay, that's interesting. Okay. So let me just reset it, make sure. Oh, how interesting is that? I'm gonna have to show the guys this. It's like, why is Karel already on the finish line when I click through? Okay, so things we learned, right?
The program.
Yeah, exactly.
Have you hit restart yet?
I did. But let me run it again, because it'll allow me to reset it. And now when I go back, yeah, I see all the flowers, but not that one. Ooh, I'm going to write a bug report because I know there were flowers there before. So it didn't reset all the mazes.
Does it randomize it and just not always put the same number every time, or?
No, not at this level. When you're creating your own Karel programs, there's a lot of things you can randomize, but once you publish the maze, it is what it is, unless it's pre-populated. So yes, someone has put orchids here and then put orchids there. And then whatever happened to our third maze,
Yeah.
it's there, it's just not showing. Yeah, but okay, so there's a perfect example, and it works. You know, you would never notice it unless you went back to examine it, and then all of a sudden you see, wait a moment, what happened to that third maze? You know, it's not displaying, it's showing as already solved. So I'm thinking now, what is this bug? And I'm starting to think, oh, we're not resetting all the mazes for some reason. So so now I got a bug report to write. But that's exactly it. So conditional programming is pretty neat because now you've got that versatility. You know, you can solve for conditions you don't know in advance. This is pretty neat stuff. All right. Well, I'll be quiet until I get the next question. So this is great. I'm glad you guys are doing it and asking questions. I'm going to talk over you a little bit while you're still working. I just wanted to show you the guide that I'm preparing that includes a lesson plan, among other things. I wait to publish it until we've done the webinar because you always have such great ideas. Here we have a simple list of learner outcomes, but more importantly, we want to use these samplers as a way to introduce people to a career path or pathway. In other words, a roadmap. Let's say you want to become a data analyst. Well, how do you get from zero to hero, as they say? So you could start by taking this mini course first. And like I said, that's either in the browser or they can create an account so they can access all the courses. Then it would be really good for them to take the full course because, as you know, if you've done it, it goes into a lot more depth and complexity than the sampler. If they wanted to start playing with Python, and this is what we'll be looking at next week, the Visual Intro to Python course is a nice way to get started because you are coding in Python, but you have this, again, a visual output that's easy to see whether you've succeeded or not. If they were going, okay, I want to keep going, they might want to take one of those other samplers. So you can see down here, we have a SQL sampler, a predictive data analytics sampler. There's also a linear algebra sampler. And then up here, it goes from intro to computer programming to visual to a full Python programming sample. So these are, again, they're ways to test the waters to see whether they want to make that commitment. They can also use the Career Explorer tool that you have at your libraries to plot a pathway. Some of you do have career centers at the library, or even if you don't have a formal one-stop, you're very often working, you're giving personal guidance to people. I've seen that at the libraries, very kind librarians helping people with paperwork. And then if they're interested in what they would learn at college, and again, I'm promoting our programs, we have 2 pathways, and these links go to those pages to explain what's involved in that. And these in Nevada right now, it's offered through UNR, TMCC, Great Basin, College of Southern Nevada. And we have several colleges around the country, but those are the ones that would be of most interest to Nevadans. These programs, we give them a full 2 years. They're multi-course, and they do a capstone project at the end. They're very dedicated people, get them done in 6 to 8 months. I'd say most people take about a year to get through the courses. So that's an idea of a pathway. And we do help them with job prep and so forth. So hopefully by the end of all this, they have a job. They're in the loop. as stepping stones. Now, this is a little bit more, okay, how do we do this? Okay, you're going to start having kids dumped off after school again, like you used to in the old days. They have to have something to do. So this is sometimes you can work with them and point them in a direction, either as a group or individually. Definitely people who think they might want to take the big course but aren't sure. It's a great test drive. Is this a good fit for me? And it's also a gentle way of bringing people in to programming. I've seen this for people who really have no idea what programming does. It's magic. It's like, oh, instead of writing go, 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 I write repeat 6 and write go, and that's 2 lines, and it does all this. And then, oh, if I write a condition in, it's going to conquer the world with all these different, messy situations. It builds a lot of confidence in programming before they hit that language. The K-12 version, right now, like I said, it's just a clone right now. If you see it on the desktop, we haven't simplified the language, so you're not going to get all that technical stuff in there. That's really more for kids. It'll be explained in a much simpler way. It'll also be useful for people who are, say, English second language. They just want to get a feel for it, but they don't want to drown in the vocabulary. So that's going to be a good fit for people like that. So that's the outline of the course and a little bit on logistics and what it'll work on. It won't work on a phone. A large tablet is okay. As you can see, you're looking at the outcomes visually and you're typing at the same time. So you're still better off with something with a real keyboard. I don't think anybody's using Internet Explorer anymore. That was a problem in the past. It's fine on Edge. Microsoft Edge is just fine. It works fine in the Windows environment, the Mac environments, Linux, so forth. They do get a certificate at the end. So this is where, okay, this is a little differentiator here. If they're doing it on the browser and they want their certificate, they do need to enter their email address at the end so that it'll send it to them. Okay. So that's a decision. You probably don't want young kids doing that. You're better off to put them in the desktop environment. If your computers aren't hooked up to the printer, I'll send you some blanks. You can just put in the date and sign them and their name and hand it to them. So that's an old-fashioned but great way to handle that situation. Yeah, there's the links, the samplers. That's the samplers, and there's the direct link to that one Karel one. So that's just logistics, a little bit about accessibility, advice on preparation. If you're going to teach it, do it first. And as you can see, it doesn't take that long. But then, you're really enough of an expert to help them out. Always do your tech check if you're setting up anything with a group. Okay, and here's a sample lesson plan, and honestly, you can play with this. This is where I might want to put up some posters on the wall that they can play with. And these are the type of questions I would ask. Karel's a robot, so what do robots do in real life? A lot of people have a fantasy movie idea of what a robot does until they realize just how many devices are doing things for them. And those are all basically robots, and they're programmed. Your car is programmed, your refrigerator is programmed. It's got a set of controls that are run by a program. It's an autonomous robot. And another paired question I think is interesting to people is when you're writing a set of instructions for a computer, what does the computer do? Well, the short answer is it does exactly what you told it to do, for better or for worse, right? If you give a set of instructions for a human will immediately start figuring out, okay, this isn't quite working. What do I have to do to fix this? We're very sophisticated, self-correcting computers. We're problem solvers, right? So, and that's an important distinction when you get into programming. Computers are very fast. They can be very reliable, but they're limited in what they can do to what you give them for instructions. Whereas humans, you can throw them into a situation and humans will start figuring out 10 ways from Sunday to solve that problem. If you do need to do a walkthrough, like we did a little guided practice, I would take them through that first exercise and then let them loose. You can always have, you know, group A, hey, if you want to get started, go for it. Group B, you want a little help getting through the first part? Come over here, let's work on it together. Definitely you're going to have some self-paced practice time. That's going to really vary how quickly they go through it. If you have enrolled them in a group, you can check on their progress using My Students. And then you want to build in some pause points. So if you've got a group of real newbies, some of them are really afraid of making mistakes. They've been punished forever with grades, making mistakes. And this is something they have to get over it if they're going to get into programming. This is part of the routine of programming. Like we noticed, there was something weird about how those mazes were refreshing when you were still on that level. They were still showing as solved as opposed to refreshing Karel from the beginning at each maze. Now, when I jumped out of the program and jumped back into it, it reset everything. So as a human, I've got to work around. Is that acceptable? It's probably what we would call a low-level task for a developer. It's not going to kill anybody. But we should fix it at some point when we have time, you know. And sometimes when we're meeting as a developer team, it's like someone will say, oh yeah, that's 1 hour worth of work. I'll get it done this week. Or they'll say, oh, this is actually more complicated than you think it is, and we might have to schedule it in. So this business of making mistakes, you know, these are just guiding questions. What did you learn from it? How did the program tell you you made a mistake? How did you fix it? Did you change how you approach the program, the problem? Maybe you were really going at it the wrong angle completely, and you changed your approach. And this is all part of the problem-solving process. Sometimes people get stuck on the point of view. How is Karel looking at things compared to you? Remember, we have the bird's eye view of Karel. We see everything. We see all the objects, the obstacles, the containers, the home square. All Karel sees is what Karel is on, the square that Karel is on, and what is directly in front. Karel is blind to everything else. And that's an important understanding in robotics, that robots are limited by their sensors. The fewer the sensors, the more limited they are. So that's an interesting lesson. And then you might ask them, well, okay, we've had all these simple commands. What's the equivalent of go left, right, get put in a real life robotic situation? So these are all kind of, some of them are, okay, they're empathy questions or they're review questions. And some of them are extensional. They're going, okay, all right, how does this work in the real world? At the end, I would start looking at, well, what kind of job can you do where you might write programs? And that's including programming robots. And I just put a list of some ideas in all these different fields where that might be something that they want to go and do a web quest on. Just explore it. They might explore it in Career Explorer. Oh, wow, I never realized that you used it in farming. Okay, I'm going to look up farming and explore that. And there's farming. I live in a ranching farming community in Winnemucca. It's amazing how much is being automated. You know, cows getting radio tags. The guys around here, guys meaning generic guys and women, use drones all the time. They're checking for animals. They're checking for bad watering patterns, all kinds of stuff. So this idea of, and what is a drone? It's a robot that flies, right? And you can automate it. You can just run a program where it starts from home, it flies a pattern, records data, and lands back at home, and you haven't laid a hand on that thing. That's an automated That's an autonomous robot. So I think these are, you can really start having a conversation over what you're going to apply this to. This is going to pique their interest and might give them some confidence, because they might go, oh yeah, I've worked in shipping forever. I can see where I could work on automating it or analyze data that would help solve my shipping problems. So a lot of people come from a point of view already. And if you marry that previous experience with what they're learning now, this is quite powerful. What to do next? Okay, let's say you have a group. Obviously, some people are going to blast through this little sampler, and then they're sitting there twiddling their thumbs. So if they're in the desktop, or if they're on the browser, they could go ahead and just try another sampler. They can do some exploring there. Or they could even explore one of these ideas. If they're in the desktop, they can go ahead and start building their own Karel game in Creative Suite. If they feel like, okay, I want to get into the course, all the library accounts have the full course. They could start working on that full course. They could switch over to Career Explorer. So these are things they can do during the session. These are things they can do to follow up. Again, thinking in terms of that pathway. So we're not just going, okay, here's a cute thing you can do after school, people. What does that lead to? So that's where that dialogue is. So getting back to where's everybody at?
So I think me and Ben have finished all of the ifs, the 3.3s.
Okay.
And, we're sort of just like following along with you and about to start the little white statements or whatever, the conditional loops.
The while loop, yes. Yeah. All right, and Lori, you just got to the sampler, the certificate, right? So that's a printable certificate, and with a very little effort, you got a bit of a reward for your work. So hopefully that's working as expected, and of course there's the little plug for, okay, this is what you can do next. We use these samplers when we're, like I said, when we're checking to see if someone really is ready for that full college level program. If they get through this with ease, they'll come back and go, yeah, I can do this, no problem. And can you see how it's not just me evaluating you, you're self-evaluating what you can and can't do, getting your own comfort level, both in the method of learning and the content that you're learning. All right, so we have some, do you want a few more minutes just to work on this before we close out?
I mean, what do you think, Ben?
I think I'm pretty good for now. I'm more interested in some of the other sessions we're going to have further on when we go a little bit further beyond.
Right.
To see how it works for users that are ready to move on to more advanced content.
I did have one quick question on the while loop stuff. So, like I remember doing stuff like this back in, like programming 101 or whatever, programming the little robots to go through the maze. So you said that Karel or whatever, it only knows what's in the square, and in that case, that's where the get and put and all those commands come from. And it knows what's in front of it, and that's what the why thing. But sometimes the if is also its own square, right? Like if or get. So is there like a color coordination here for determining like which of these words in the Karel programming are looking at the square in front of Karel versus the square that Karel's in? You know what I'm trying to say? Right.
Okay. So no, you don't need color coding, but it's very simple. You actually you nailed it. If it's an object that has to be collected or put, so get or put, it's underneath Karel. If it's an obstacle, it's sensed in front, because obviously by the time you get on top of that obstacle, you're dead. You know, you're crashed. So that sensor in front is for obstacles, including walls. And so Karel can always, any given position, can sense a collectible or a container underneath itself or the ground. You can put something on the ground, at the same time, it's able to sense what's in front if you tell it to look for it. So if you say, Karel, just keep going, it'll respond to your command, it'll go. But if you say, Karel, if wall left, okay, it says, I got a wall in front of me, I'm turning left. So if is always in the moment, while is controlling how many times you repeat those commands. And there's a lot of ways you can use it. You can use while you have a wall, you're going to do this. You can have while you're not home, while not home. So you're just going to keep doing it until you hit the home square. You do want to have something that stops that loop, you know. You can have while not wall. So let's say you have something with long corridors, right? That while loop says you're just going to keep going until you hit that wall, until you sense that wall. I should say hit, until you sense the wall. So while not wall go means you're just going to go, 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 go. And, oh, I just sensed the wall. I'm going to stop, or I'm going to turn left, or whatever the case may be. So it's like a repeat loop that is conditional. That's what it's doing.
Okay, makes sense.
I could even see, prior to having students on a computer, like giving them a pair of sunglasses or just like glasses with no lens, but putting a blinder on the sides, and then having one person direct them where they need to go, and they're practicing moving left, right, picking up, but they can't see anything but straight in front of them, and they just leave an open space so they aren't going to run into anything. But then they start understanding the robot's perspective. They're waiting for a command. They're waiting to follow the direction, and they can't see anything but what's right in front of them.
That's a very visceral experience, and it's a good one, because I think we romanticize robots, especially kids. You know, they live in a magical world where robots are incredibly smart, intuitive, powerful, giant. You know, they shoot all kinds of cool guns and stuff. In the real world, they're very limited, and sometimes you want them to be very limited. If you want something to do the same thing over and over again, with maybe you might throw a heat sensor on there, you might throw a vibration sensor on there, a few other things, but you really don't want it to do anything beyond the task it's assigned to do. You want it to stay simple. You want it to build it. You want to build it to be reliable. And task specific, and that's very much the case in, say, manufacturing, where you're cranking out 1 million of something an hour. It's not going to be a fancy robot. It's going to be highly limited, with exactly what you need for it to function properly. So yes, the idea of a blindfold, oh yes, and they have to trust that program, which is interesting too. And then of course, when they're on the other side of it as a programmer, they kind of have some power there. So any other thoughts? How are you doing, Sarah?
I am doing okay. When you had started talking and going over some of the curriculum and other stuff that was offered, I had stopped working on the coding. So I'm pretty much still where I put in chat.
Okay, great. Well, you probably would get it. You probably finish it out, though, right?
The sampler, yeah. I can finish it later.
Right.
I'm not the fastest coder, so it would probably take me a little bit longer.
So this is a good point. So when you're doing this, obviously individually, it's not an issue. If you're doing it in a group, you're going to have some people who whip through it, and you're going to have some people who need to think about it. Okay, so we all remember who won the race with the tortoise and the hare, right? Mm-hmm. So it's not anything that is a problem if you take time to absorb learning. A lot of times the tortoises are the ones who get it more solidly than the hares that kind of finesse their way through, but haven't really built a deep understanding. So you're going to find all kinds of types. And like I said, this, I worked with this one lady who, oh my goodness, this is a real new world for her. And I walked her through that beginning of Karel. And there were a lot of things that she would never have figured out, but that's all it took. I got her through 1.2. She went all the way through the rest of the Karel sampler, and she's almost done with the SQL sampler. So that is, there are going to be times when you need to give that nudge. The other thing I can see this as is if you are working with fellow library staff, this is not too hard to do, is it, to do the sampler? It's not like digging into the full course. If you've gone through the sampler, you at least have a feel for how it works, and you don't have to be an expert.
I think almost with younger kids that I would go back to Karel the Robot, like the original course, because it meant much slower. There was less reading. Mm-hmm. If I remember correctly, like it would say like, this is how you go, and then this is how you turn left, and this is how you turn right. And it really broke it down more. So I think depending on who you're talking to, guiding them towards the right program for them. Like if I'm going to do a coding camp for little guys, well, I may not even start on the computer, first of all, but like that's where we may end up, is just starting on the traditional Karel the Robot, because it breaks it down more.
Yeah, and it has that the whole first section in the main course is manual. So that's a tactile way of feeling the program. Mm-hmm. I am going to take this sampler and write it in simpler language for, like I said, both younger people and people who don't have strong academic language skills for whatever reason. Because you're right, you don't want to learn you don't want to know the equivalent in COBOL when you're struggling with language, or you just want to play a game. You don't need either of those bits of information at that stage. So what we call the K-12 version will be a lot simpler. I think on the K-12 one, I'll throw in some manual exercises to start them off, so they can get the feel for how the controls work before they start typing. So thank you, Lori. Yes, I agree, and I'll guinea pig you on the K-12 sample, or anybody else who wants to see how it works with a little bit different crowd.
I know we also, like at Sierra View, we have a coding mouse. It's like a little toy, basically. Mm-hmm. Where you tell it, like you type in, forward, right, left, and then it goes where you tell it.
Yes,
it's basically
those are
like
great.
Karel, but they can see it.
Yes.
And they can experiment with that. And then once they play with that, then I think they would understand better what they're putting into the program, because they'd be like, oh, it's the same as the forward button on the mouse, or it's the same as the right button on the mouse, or the left button.
Which
Especially
is great
for that perspective.
Yeah.
Like to know which direction you're talking, which direction you want Karel to go, not which direction you're going.
Yes, and that's a big difference. And actually, when I was working in elementary school, I used Karel to help students who had difficulty telling left from right. They were happy to spend all day long in that section 1, and I was impressed. They actually figured it out. I think partly because it's game based. It's game based training. So. So yes, I'll let you all know when the K-12 one is ready, because it sounds like you do have still quite a number of younger audience that could use it, and then you know the difference. And the people who are more career oriented might want to have that other context as why am I learning this? Oh, because that's how procedural languages work. Okay, I get it. This is important. Erin, any thoughts from you before we wrap up? Erin, Erin.
Okay, I was like,
no, I'm good.
Okay. And one thing I did this morning, I had a conference call with a librarian from a different library who was new, and I just walked her through how the desktop works, how my students work, how the courses work. So if you ever want a one-on-one session, just holler at me. We'll set up a Zoom meeting, and go over some things. So I'm happy to do that. That's what the state's paying for. They're paying for some support, and I'm happy to offer it. All right. Well, final thoughts before we go.
I'm gonna finish all of these and then probably contact you.
Sorry, what was that?
Oh wait, I'm gonna finish all of these practices and then probably ask for another meeting later. Just to make sure I've got everything down.
Yeah. I wrote down some of your comments. I think we might need a couple of explainers in there. If you see anything at all that you feel wasn't clear, that could use a little elaboration, or rewording. Sometimes it's just a matter of rewording. Just shoot me an email.
The only thing that I would say is that there is a pretty significant jump in difficulty, I think, between 3 and 4. That's to be expected. Yeah. Like 1, 2, and 3, you can just, and then even 4, once you understand how it works, it's not that bad at all. But like it's a pretty kind of spike there.
While loops are a difficult idea to understand.
I mean, like, not something you don't know. It's just like, how do we teach this first really difficult concept? Yeah.
They might have to sweat a little bit first. And actually, when you look at really, sometimes you got to get them to sweat, and then they're ready to listen. But when you start looking at those mazes, let me just move this chat box so I can move my cursor. Okay, that one's not so bad. I'm going to go to the really impressive looking one here. Okay, so you look at that maze and you go, all right, what on earth? And I got 4 different mazes, and the home square is different. The starting square is different. There's left and right turns. There's skulls that are obstacles. There's keys I have to collect. How do I deal with all this? I don't know. And so, yes, this is going to, but actually the code is really simple. And I'd encourage, it is. So while you're not home, so that's your stopping condition there, right? Okay, you're going to do all this stuff until you get home. You're going to go forward. If there's a wall, if you sense a wall, you're going to turn left. Okay, what happens if there's another wall? Well, if you're going to sense another wall, you're going to turn around, and that can be left or right. That'll turn you 180 degrees. And then, of course, if you see a key, you get it. Okay, what about the skulls? Well, if you step through the program, and I won't because it'd take too long, you're going to find out you don't have to deal with the skulls at all. The maze is set up so you never run into a skull. So this is, in math, they call it, I've forgotten the word for it now, but it's a fact. You'll set up a word problem, and there'll be some information there that you don't need, right? When you're designing your solution to the math problem, you go, I don't have to deal with that piece of information that's totally extra to the problem. I don't need it to solve it. And in this case, these little skulls are behaving that way. They're extra information. And as it turns out, when you run it, you never run into a skull. Yay.
And if you click the give a hint, it gave that hint as the left and the right.
Yep.
Because I was getting stuck on that.
Right. Okay. And if we submit, we're going to see, this really beautiful, simple little bit of code that we wrote, and it is simple.
Yeah.
Works on all of these situations.
Which is kind of silly, but I love it.
And so I think, yes, it might, and this is where this is neat because it looks horribly complex, but you start breaking it down and it's not. you know. So now they're getting introduced to, okay, this is what real programming is like.
Yeah.
Is sorting through the weeds.
Yeah, the previous repeat tasks had more lines of code than that.
Yeah, yeah.
Yeah.
I mean, it's just, look at it, it's beautiful. It's elegant. It's 9 lines of code and it handled all that. So yes, don't worry if they sweat a little bit. They need to do that. And you know, you guys have the solutions. If you have to jump in, if you have to give them extra hints, you can. You know, it's that's a judgment call as a teacher. Is at what point do you relieve their pain, or you know, what breadcrumbs do you give them?
I know we're 5 minutes past time. There was actually one bug that me and Ben both saw that on 3.1, the instructions,
Looks like there's
the colored A's tabs images are broken. Yeah. So if you go
really?
back to like the demo if you
yeah,
go like
3.1 demo program.
Yeah, it should be the 3 of 4, I think. Yeah, so see how yours has that?
Oh, broken link. Okay, we'll get that fixed. That's a. I can tell you what that is. That's a file copy problem. For colors. Okay, great. Thank you for letting me know. And that's on.
I mean, it was on both of our machines, but I mean, I don't know if it's for anybody else.
No, that's a real bug. I'm a super user.
The laptops you might be using during.
No, it's not your. It's actually not your end. It's ours. I'm what's known as a super user, and I probably have those files in a different folder, and they're recognized. This is a file folder issue. Welcome to the world of programming. But that's actually, I'm glad you found that, because I know they've been working on that one. So this is good. Good to know, and we'll get it fixed. So, well, we did go a little overtime. I hope you enjoyed that and you learned something out of it.
Yeah, I look forward to talking.
Thank you.
Okay.
Thank you.
Go ahead, Sarah.
Sorry. You talked about at the beginning of class the difference in the users, and you said that was going away, right?
I'm not sure what you're referring to.
You were talking about the I users.
Oh yeah, the I users are, they should have been all extinct, because what we really want is anybody who's an instructor to be email based. That way you can correspond with us.
Okay, I am not email based. Took me a few minutes to find my login and pass, the NVLIB. Is that different from, as I said, regular user, not email?
Well, Sarah, why don't you email me with the address that you use to log in? And if it's associated with an email, it might be a really old one. But yeah, it will. If there's any progress, I can keep it in there for now. At some point, they're going to get deleted from the database. Period. Most of the library accounts, we've gotten rid of the I accounts, the I users, because again,
it sounds like at Sierra View, we have a list of like 30 usernames, and they're all like SV lib 1, SV lib 2. Those are going away, and we want them all. No, those can stay.
Only if they have an I in front of them, because I stands for instructor.
Okay.
So what Sarah has is probably just a patron account, like a NVLib number. And
yeah. No, that's just a user account. That stays. You have to be careful with those, because they can be deleted, and if they get deleted, you can't bring them back to life. Whereas an email-based account, all the data stays with that user. So that's why we want the librarians to have email-based accounts, because if you go from Sierra View to Spanish Springs, I can just take you out of one library and put you in the other, and you have everything you've done is there. It goes with you. So yeah.
So if like I had a SV lib one and then when I logged in, it didn't show my progress, is that something different or is that the same?
It might be because you were in an old version of the course and I cleaned out all the old versions of the courses.
Okay, so
Yeah.
could we just pick up where we feel we left off then, or will it make us
Yeah.
restart?
Well, the thing
Okay.
is that with the email-based one, as a teacher and an admin, you
Yeah.
have open access. So you have an unlocked version of the course.
Okay,
You don't have to do it step by step like a normal user would. You can
but if we
start
have
wherever you want.
patrons that have the SV lib ones and when they come back, if their progress is not saved, what should they be doing then? Like if it's changed?
Just let me know, and I can show you how to unlock, because you can.
Okay,
You can unlock their from the student panel, or even if they're on their machine, you can go over and unlock it. It'll ask for your credentials, but you can
Okay.
unlock a course to any point. If they said, "Oh, I was all the way to section 7," you can unlock it all the way to section 7. So,
Okay, that's what I want to know for our ones that come every week, that maybe when they come back after a year and a half, it may be different.
chances are they're in the current version.
Okay.
So they should be okay. The Visual Python is the only one that we upgraded to a 1.3 version because it has 4 units now instead of 3. So it's structurally different. Everything else is still 1.2, and that's been around for a few years now. So hopefully they were in 1.2. If they're in 1.1, it's gone, but we can just give them credit for wherever they got to and they
Okay.
keep going. Yeah.
Thank you.
All right. Okay, guys. Well, I hope to see you next
Mhm.
week. Please invite your friends. And we'll tackle Visual Intro to Python next week. So
Awesome.
Okay.
Thank you.
Good. Thank you.
it was
Thank you.
great
Thank
to see you
you.
all again. I'm so glad the libraries are opening. Next up, in webinar number 2, we will explore the Visual Intro to Python Sampler mini course. This is a great next step for beginners after they have learned computer programming concepts in Karel. On behalf of NCLab, thank you for participating in this webinar. We hoped you enjoyed working through the samplers. Please reach out with any questions to support@nclab.com. You can also contact me, Sheila Crawford Bunch, at sheila@nclab.com. Thanks to all the libraries for being such a vital part of our communities.